All right. So more review of power series. This one I'm going to be adding series together, and this is one very important 462. What we want to do is get this whole thing into one series, meaning that I only want to see one sigma notation. Okay, so what you want to do, I think the best way to do this is take a look at the exponents that x is raised to, all right, and make your k equal to that value. Okay, when you do that then, and if you solve for n, right, this will wind up being k minus 1, and think about if you plugged k minus 1 in here, you would just get x to the k. And same thing here when you make n to be k plus 2. If you plugged it in for n there, you would just get x to the k. And that's really the idea there, that you want to have those x values the same. Now the thing that is a little bit tricky is you do want to make these two start at the same value. So, if you know n is going to be 2, right, and this one k would be 0. Oh, sorry, I know I'm just talking. Okay, so think about this. If n is 2, right, if you plug that in over here, k would equal 0. But on this one, if n is 0, you're plugging it in here, you would get k to be 1. So what we want to do is make sure that these match. Okay, so the easiest one to deal with is this first sequence that we have, because if n is 2, right, and then I plug in that 2 for n, I'll get k to be 0. If I add one more, I'll get that k to be 1. So how do I do that? Right, so you always want to work with the one that's lower. I'm just going to erase a couple things. Okay, so I'm going to plug the 2 in everywhere you see an n just for that first series. And when I do that, I'll get 2 times 1 c sub 2, and then x to the 0, which will be 1. And then you add, because sigma means add, and then this becomes an n equals 3, right, because you plugged in 2, and just remember the next one would be 3. And then you would have the same series, right? So 3. So 3, and then you would still have the same thing going on here, because I didn't really change much yet. All right, now if I plugged in n to be 3 here, I would get 1, and if I plugged in 0 here, I would get 1. And that's the other thing. You want to make sure that it starts at the same thing, so then you could combine it into one series. All right, so what I'm going to do now is everywhere I see an n, I'm going to plug in for the first one, k plus 2, and for the second one, k minus 1, okay? So what happens is it's going to look like 2c2 plus, so if n was 3, I know I'm going to do k equals 1 to infinity now. And everywhere I see an n, I'm putting k plus 2. So I'll have k plus 2, k plus 1, c sub k plus 2, and then x to the k. And that's really the thing that you'll know. The x to the k, that's why you're going to always make k equal to the exponents there. And then you have minus, now n turns into a k, and if you plugged in 0, right, if you plugged in 0 here, right, we would get 1, and then that's good because the starting value matches. All right, and then here I would just have c sub k minus 1, and then x to the k, and that's good. So the next step would be just to combine and factor, right? Because they both have an x to the k, so I just want to kick that out, right? I want to get this into one sigma notation, right? So I have k plus 2, k plus 1, c sub k plus 2, minus c sub k minus 1, and now you have this written into one single summation or series. All right, so I'm going to do, this is the first thing, and you kind of want to practice that first, and then I'm going to do one intro type problem for 6-2 soon using this method that we have right here. We're going to start to solve these differentials using series. All right.